Okay. All right. So let's take a look at this. Calculus 2, related rates. Solve it. All right. Now, approach related rates problem by writing an equation involving a time-dependent variable. Okay, so everything is in terms of time for these things. Okay, it's obtained by investigating the geometric and/or physical condition imposed by the problem. We then differentiate the equation with respect to time and obtain new equations that involves the variables and their rates and changes with respect to time. Okay, so now right here. Golfer hits a ball into the pond of still water, causing circular ripples as shown in the figure. That if the radius of the circle increases at a constant rate of 0.5 meters per second, how fast is the area of the circle increasing when the radius of the ripple is 2 meters? Okay, important things. Area of the circle, okay, and it's actually asking how fast the area of the circle is changing. So, it's a change of area, right? Say yes.
Yes.
It's a change of area. So now, how would I denote? How would I write down stating that I'm finding the change in area? Okay, so yeah, dA dt. That's what I'm looking for. Okay? And it says that the radius is changing. Radius is changing at a constant rate of 0.5 meters per second. So what am I going to say that's going to be? dr dt. So it's the change. So dr dt is 0.5 meters per second. Okay? And, okay, how fast is the increasing when the radius of the ripple is 2 meters? So what is this going to be? The radius, so that's going to just be r, right?
Yeah.
Okay, so r is 2 meters. Okay, so now, if I have a dA dt, that means at some point to get that, I had to have an area formula, right? That's what I'm looking for. I'm looking for the area changing. So now, to get to this one right here, I took the derivative of the area. So my area of a circle, A, is equal to pi r squared, right? Say yes. Okay, good. Area is pi r squared. It's not p r squared, it's pi r squared. Okay? So we're going to take the derivative of this in terms of time. Is there any times in there? Say no. None of these have time, right? So we're going to take each variable with respect to time. That's going to be, when I take the derivative of my A, I'm going to get my dA dt is equal to, now take the derivative of r.
2 pi r.
There we go.
But then we have to do the
2 pi r. But then I took the derivative of r in respect of time, didn't I?
Yeah.
So when I do that, I plug in what?
dr dt.
dr dt, because I'm taking the derivative dr dt. That's just like my implicit differentiation. Okay? Because I'm taking the derivative of something that, of that variable, but not of that. Okay? So now, let's take a look. To find my dA dt here, I need to know the r, and I need to know dr dt. Do I have the r?
Yes.
Do I have dr dt?
Yep. Yes.
Oh, I do. So it's going to be dA dt is equal to 2 pi. My r was 2, and my dr dt 0.5, right? And that's going to be something per something? Meters per second, right? Okay. So, the area, okay, what are units of area here? What are going to be my units? Meters squared, right? Because the excuse me. It's dying. I don't know. Okay, the area is of the circle in whatever units that is. So it's the rate of change of the area at the certain time. So now for this, I'm going to get, that's going to be half of 2 is 1 times this. So it's going to be my change in area over time is going to be 2 pi units, meters squared per second.
That's 2 also is 2 meters.
Per second per second?
No. Because there's only 1 second.
Yeah, so 1 second.
But there's 2 meters.
Yeah, 2 meters. Is that what you're talking about?
Yeah,
Like where the
square.
2, this is 2m?
Yeah.
Is that what you were talking about there?
Yes.
Okay, yes.
So it's just not just arbitrarily just squaring meters. There's actually-
Oh, yeah. Okay, thank you.
That's why I was asking you for that one. 'Cause I
Oh,
didn't see
yeah.
what the second meter was. But then I realized.
Okay, yeah, but that was your work.
Mhm.
Okay. Anyway. All right, so let's take a look at this next one then. So like I said, read the problem carefully, perhaps several times, pay particular attention to rates that you are asked to find. If possible, draw a picture, illustrate, identify variables, assign symbols to them, label picture, identify rates of change as derivatives. Be sure to list the units for each variable, rates of change, indicate what is given and what is asked for. Step 3, write an equation that relates to the variables. It may be necessary to use more than one equation. Differentiate both sides of the equation. Substitute numerical values for the variables and the derivatives. So for the unknown and solve for the unknown rate. Okay, all that. It's spherical. Spherical. Balloon is inflated at the rate of 10 meters cubed per minute.
Final.
Okay, so good. So what is that information going to give me? Is it cubed?
Yeah, it's volume.
So therefore it's volume, right? Is it a rate of volume?
Yes.
It is a rate of volume. So I would write that as
dV over dt.
is 10 meters cubed per minute. Okay. Find the rate. Find the rate in which the surface area of the balloon is increasing. Surface area of the balloon is increasing when the radius of the sphere is 3 meters. Okay, so what other information do I have?
The radius.
Okay, the radius is 3, right? So radius is 3. So R is 3 meters. And surface area. Ouch.
Yeah, that's a.
Okay, surface area. Okay, but now I'm going to be dealing with 2 different equations, right? Because I have a rate of the volume, but I'm asking for the rate of the surface area. The area is going to be increasing. So now I know that I'm going to get a dA dt, right? To stand for the surface area of that. So if I have a dV dt, I know that I also had to have an equation of a volume, right?
Yeah.
Okay, so let's see. So I know I have volume is equal to 4/3 pi r cubed. I also know that my surface area, my SA, is equal to, you guys remember surface area of a sphere? What is it? 4 pi r squared.
Whoa, that's crazy.
Are we okay here?
Yeah.
Okay, so now let's look at all the information that I have.
Yeah.
So I know I'm looking for dA dt, right? It might look complicated, it might look confusing right now, but I know that I'm going to end up with this value over here, right?
Yes.
I'm going to end up with a dV dt, and I know I have to find a dA dt. All right, so let's go through and actually start finding some of this stuff then, right? I know I'm eventually going to have to take the derivative of the volume and the derivative of the surface area, right?
Yeah.
Yes. So let's go ahead and do that. So if I take the derivative of the volume, so dV dt is going to be equal to what?
4 pi r squared.
4 pi r squared.
Oh, d a dt is d
R.
r dt, right?
Yeah.
You derived r.
Yes. Take the derivative for r. in terms of time.
Yep.
Okay. Okay. All right. That's some useful information. Okay. Now, let's do the surface area, right? And I'm going to use the notation of dA dt for this one. Okay. Surface area. So dA dt. So let me separate that. So dA dt is going to be equal to 8 pi r, right? dr dt.
What's our dr dt?
Okay, so there's a couple things I need here, right? To figure out my final answer is looking for the dA dt, right?
Yeah.
To get the dA dt, I need to know what the r is. Do I know what the r is? Yeah, I do know what the r is, but do I know what dr dt is?
No.
I don't. But can I use this other thing over here to find it?
You know what dV dt is?
I know dV dt, so I could actually substitute over here for my volume to actually go and isolate that part of my equation. Right?
Yes.
So let's say that this is going to be my 10, okay, meters cubed per minute, right, is equal to 4 pi r squared dr dt, right? So I want dr dt by itself. So what am I going to do to both sides? Divide by what?
Divide by 4 pi r squared.
Very good. Divide both sides by 4 pi r squared.
It's like a
So I'm going to get a dr dt is equal to 10 over 4 pi r squared. So I could replace my dr dt with that, right? Okay, so that's what's going to happen over here on this side. So it's going to be dA dt is equal to 8, right? Pi, right? Now, when I'm plugging this in, okay, it's going to be r times 10 over 4 pi r squared. What's going to happen when I do that? What's going to happen when I do that? Pi's cancel. One of the r's cancel, right? Okay, what about that 4? So, dang. So what am I going to be left with?
20 over 30.
So it's going to be dA dt is equal to 20 over, and since my r value is still there, right?
Yeah.
The r value, and I can plug that in, so it's going to be 3, right?
Yep.
Now, what are my units here? Let's go back and talk about this. So I got a value for this, so 20 over 3 is my answer. But now, what is it we were talking about when we found this answer?
Surface area.
Surface area. Very good. Surface area. And area is always square. So now area is always square. So what are my units that I had here?
Meters
Meters.
per minute.
Okay, so this is meters squared per my unit of time is what?
A minute.
Minutes. Not bad, right? Hopefully. Did I confuse anyone?
No.
No? Any questions? Because this is where I'm leaving off today. Okay. All right. Don't forget, like and subscribe.
Notifications.
Yeah, turn on notifications so you got those. All right.